Welcome back to today's session. Till now, we have completed the unit number 2, which was all special cases of LPP. Today, we will be starting off with a new unit uh, in your syllabus. It is in unit 4. The concept is called game theory. So, we will be dealing with game theory. In today's session, I will be dealing with basic definitions, terminologies, and a very simple problem. Right? That is what will be the agenda for today's session. So, first of all, what is a game? A competitive situation representing a conflict between two or more parties is called a game. So, what do you mean by competitive situation and conflict between two or more parties? So, whenever a game is played, the player will have an interest to win, and the other player will also be interested in winning. No one will play a game to lose, right? So, both have an interest of winning the game. So, in this interest, there is a conflict. Player A also wants to win, player B also wants to win. There is a conflict of interest. In this conflict of interest, there is a competition between them. Who will win the game? Right? So, such a situation is called as a game. So, we will look back at the definition again. A competitive situation representing a conflict between two or more parties is called a game. So, if at all I have called something a game, then it should possess certain number of properties, right? So, a game should have certain properties. So, we will have a look at what are the properties of a game. A game needs to possess the following properties. The first one, the number of competitors is finite. A finite number of players should be involved. There is a conflict in interest between the participants. Each participant should be interested in winning the game. Only then there will be a conflict of interest between each of the people, each of the persons involved in the game. Each of the participants has a finite set of possible courses of action. So, the next move to be made in the game by the player is called course of action. So, for every player, there has to be a finite set of possible courses of action. Okay? The rules governing these choices are specified and known to all the players. See, what should be the move that you make next should be well defined. It should be known to all the players. They are called the rules of the game. See, if at all I am playing tic-tac-toe, see, I have 9 slots. In those 9 slots, I am supposed to make a marking in one place. And the rules of the game is like I should not allow the opponent to make marks in either a horizontal line or in a vertical line or in a diagonal. So these are all set of rules. These rules should be known to you before playing the game. So only then you can play a game. Only then you are a valid competitor. See, if at all you don't know the rules of chess and you sit to play chess, you don't know how to move a pawn, how to move a castle, how to move a knight, how to move a queen. If at all you don't know the basic moves at all, then you are not a valid participant or valid competition. You are not a valid player there. So, all the rules governing the choices of course of action should be known to all the players. A play of the game results when each player chooses a single course of action from the list of courses of action available to him. See, whenever I'm playing a tic-tac-toe game, let me consider. See, out of the 9 slots, I can make a mark in one of the slots. So initially I have 9 options. Out of the 9 options, I am using one option and making a mark. So that is called play of the game, right? One move that I make is called the play of the game, right? The outcome of the game is affected by the choices made by all the players. See, very simple example, the same tic-tac-toe game I'll take. See, I am one player and you are another player. So first I am playing. Out of the 9 slots, I have 9 options. I have all the 9 options available with me. I can put a mark anywhere. So once I play a game, once I make a mark, your choices are affected. So you will not have 9 options. You will have only 8 options, right? The outcome of my game is affecting the choices that you can make. That is what it means. The outcome for all specific set of choices by all the players is known in advance and is numerically defined. Okay? So whatever moves I have, see, let me say I had 9 options, I made one mark. You had 8 options, you put one mark. Now how many am I remaining with? I have 7 choices. That you also know, I also know. Right? What are all the specific set of choices available for the players will be known in advance. Say after you make a mark, my next choices is 7 options that is known to you and to me even before you play, right? So that is what has been specified here. The outcome of a play consists of a particular set of courses of action undertaken by the competitors. Each outcome determines a set of payments, positive, negative, or zero, one to each competitor. So what does this mean? See, let me say the same tic-tac-toe game, I put one mark. So your chances of victory, let me say, was 80%. Your choices of victory was 80%. So by me putting a mark there, your chances of victory, let me say, reduced. Then it is a negative payment for you. If at all by me putting a mark, maybe I didn't think of your possibilities and I have marked it in a wrong place, then your chances of victory increases. Then it is a positive payment for you. So I made a mark in some place which is not affecting either your victory or your loss. Then it is a zero payment. Okay, you understand? So this is what is outcome of every play. For every play, there will be an outcome which will be either positive or negative or zero. If it is positive for you, it will be negative for me. Because we both are competitors. Right? Then we will look into few basic terminologies and definitions. First term that we talk about is strategy. The term strategy is defined as a complete set of plans of action specifying precisely what the player will do under every possible future situation or contingency that might occur during the play of the game. See, if at all you encounter a situation, what will be your possibilities? What will be your choices of action? What will be your plan of action? That is called strategy. In other words, Strategy of a player is the decision rule he uses for making a choice from his list of courses of action. Out of all the options that you have, you will pick one of the actions, right? So that is based on some decision rule. That decision rule is called strategy. So strategy can be broadly classified into two ways: pure strategy and mixed strategy. What is a pure strategy? A strategy is called pure strategy if one knows in advance of the play that is certain to be adopted irrespective of the strategy of the other players might choose. See, let me say, in the beginning of the tic-tac-toe game, I put the first mark in the center. See, you have 8 other choices in the outer layer, right? So you can put it anywhere. See, wherever you put, I have decided where I would be putting the next cross mark. So then that is called a pure strategy. Irrespective of what you do, my next course of action is decided. Then it is called a pure strategy. Okay? The optimal strategy mixture for each player may be determined by assigning to each strategy its probability of being chosen. See, if at all it is not 100% sure that my next move will be this only, if at all my move is decided based on what you move, let me consider the game of chess. If you move a pawn, then I might move a horse. If you move a camel, I might move a castle. You move the king, I will move the queen. So if at all my move has a probability associated based on your strategy, then such strategies where probabilistically we determine the possible combination of the choices is called mixed strategy, right? These strategies so determined are called mixed strategy because they are probabilistic combinations of the available choices of strategy. So if at all, without any probability associated, if at all you know this is my next move, then it is pure strategy. If at all you are deciding your strategy based on some probability, so if this is moved, I have 70% probability that I will make a move like this. If at all this pawn is moved, then 80% chances that I will make a move like this. If at all it is based on a probability, then such strategies are called mixed strategies. Okay. So for every strategy related action, we have something called as a payoff or payoff matrix. Payoff is the outcome of playing the game. See, I said there is a payment, positive or negative or zero. The same thing here, I am calling it as a payoff. So payoff matrix is a table showing the amount of payment received by the player named at the left after all possible plays of the game. The payment is made by the player named at the top of the table. See, let me say player 1 uses the first strategy, and for that, in response, if player B uses strategy 1, then player A gets a payment A11. Payment is nothing but points. Okay? So A11 is the points scored by player A. If player A is using strategy 1 and player B is using strategy 2, then points of A12 is given by player B to player A. right? So here player B is giving, player A is receiving the points. This is called the payoff matrix of player A. See, whatever is the player's name represented in the left. So he is the one at the receiving side whose name is being written on the top. He is the giver. Okay. So this payoff matrix is player A's payoff matrix. Fine. From this, I can generate a table for player B also. So all this will be negative. Minus A11, minus A12, minus A13. If I write player B here and player A here. Okay. So that we will see here. If a player A has M outcomes, so M possible courses of action are available for player A, and player B has N courses of action, right? Player B has N strategies to make, player A has M strategies to make. Then the payoff matrix may be constructed using the following steps. In the row, we consider row designations for each matrix are the courses of action available for A. So A has how many courses of action? M. So I will create M rows. I will number them as 1, 2, 3, 4, 5, 6, 7 up to M. For the columns, it is whatever are the courses of action available for B. So I have considered there are N courses of action. So I will number it as 1, 2, 3, 4, 5, so on up to N. Okay. So row represents courses of action of player A. Columns represent courses of action for player B. With a two-player zero-sum game, the cell entries in B's payoff matrix will be the negative of the corresponding entries of A's payoff matrix. See, now whatever I have written here is called the A's payoff matrix. Player A's payoff matrix. So it is A11, A12, A13, A14, so on. See, using the same matrix, if at all I want to construct player B's payoff matrix, because player B becomes the receiver now and player A becomes the payer, so all these payoff will become negative, right? So it will become minus A11, minus A12, minus A13, minus A14, so on. Hope the concept is clear. So in games, we have broadly 4 different types of games. First one, an n-person game. In this case, the game is played between more than 2 players. Here we will have more than 2 players who are playing the game, and in general, we call it n-person game. Instead of more than 2, if at all only 2 players are playing, then such a game is called 2-person game, right? 2-person game. In a 2-person game, the players may have many possible choices open to them for each play of the game, but the number of players remain only 2. See, the players might have any number of strategies, but the number of players is always 2. Then it is called a 2-person game. Then we have zero-sum game. If whatever is the gain that I have, if it is equal to the loss that you have, your loss should be equal to my gain and my loss should be equal to your gain. Then we call it a zero-sum game. A zero-sum game is one in which the sum of the payment to all the competitors is 0 for every possible outcome of the game. That is, in the game, the sum of the points won is equal to the sum of the points lost. If I have won 10 points, you should have lost 10 points. Because you lost 10 points, I gained 10 points. If I lose 10 points, you should gain 10 points. Then the sum will be 0. If at all I have gained, it is plus 10 for me. If at all you have lost, it is minus 10 for you. Plus 10 minus 10 will be a 0, right? So therefore it is called a zero sum game. 2% zero sum game. If at all it is a zero sum game and it is played between two players, then it is called 2% zero sum game. A game with two players where the gain of one player equals to the loss to the other. It is called a 2% zero sum game. We call this game also as a rectangular game because the payoff matrix will be in the rectangular form. All my strategies will be on the rows and all your strategies will be on the columns. So how does the matrix look like? It is a rectangular matrix. Therefore, I call it a rectangular game. So every two-player zero-sum game should satisfy certain properties. The properties are only two players participate in the game because it is 2% game. Each player has a finite number of strategies. See, if the game has to end after a certain number of steps, then your choices should also be finite, right? So that is what has been specified here. Each player has a finite number of strategies to use. Each specific strategy results in a payoff. Whenever I use a particular strategy, for your counter strategy, I will have a particular payoff. One element in the payoff matrix will be present. So the total payoff of the two players at the end of each play is 0. See, if at all I make a move, I gain 10 and you lose 10, then the sum is 0. For that, you make a next move. You gained 5, I lost 5. Then also the sum is 0. So for every move, the loss of one player should be equal to the gain of the other player. That is what has been specified as a property here. Okay? So these are types of games. Then we have one very interesting and very important principle called Maximin Minimax Principle. Right? It is called Maximin Minimax Principle. This principle is used for selection of optimal strategy by two players. Consider there are two players A and B. A is a player who wishes to maximize his gain. See, I am a player A. I want to increase my chances of victory. That is maximize my gain. While player B wishes to minimize his losses. See, because I made a move, my chances of victory increases. But what is your strategy? You want to minimize your chances of losses. Okay? That is what has been specified here. Since A would like to maximize his minimum gain, see, at the beginning itself, at the outset itself, no game will be specifying that player A will only win. That is not possible. So I will have a minimum chance of victory. Out of that minimum chances, I will try to maximize or increase my chances of winning. Right? So that is what has been specified here. Since A would like to maximize his minimum gain, we would obtain a value called maxi-min value. So for A, we call it as maxi-min value, and its corresponding strategy is called maxi-min strategy. So for my move, it was maxi-min. When I look at it, from your point of view, from my opponent's point of view, since B would like to minimize his maximum losses. See, you are trying to maximize your, sorry, I am trying to maximize my gain. So when you look at it, for you, it is maximum losses that you are seeing. And what are you wishing to do? You are trying to minimize that maximum loss. Okay? Since B would like to minimize his maximum losses, we obtain a value called minimax value, and its corresponding strategy is called minimax strategy. Okay? When these two values are equal, if my maximin value is equal to your minimax value, then the value that is bringing in equation between the two players is called saddle point, right? We call that value as saddle point, and the corresponding strategy where the saddle point is found is called optimal strategy. Here, optimal strategy is nothing but giving a fair chance to both the players to win. I am trying to maximize my minimum chances of gain, and you are trying to minimize your maximum chance of loss. So if this value becomes equal, then it is called optimal strategy. Okay? Where both of us still are equally fighting in the game. Saddle point. A saddle point is a position in the payoff matrix where the maximum of the row minima coincides with minimum of the column maxima. The payoff at the saddle point is called the value of the game. See, when you solve a problem, you will be able to understand this concept better. See, when it is told in English, just in form of sentences, understanding it is not so very easy. But when you look at the problem, you will start feeling, this is such a simple concept. Right? You will start feeling it as such a simple concept. Okay? If maximin value is equal to minimax value is equal to 0, then the game is said to be a fair game. If maximin is equal to minimax, but it is not equal to 0, if it is a non-zero value, then the game is said to be strictly determinable game. Then we call that game as strictly determinable game. So we'll take a very small problem. You will be able to understand the concepts very easily now. So this is a problem given. Solve the game whose payoff matrix is given by 1, 3, 1, 0, 4, minus 3, 1, 5, minus 1. So there are 3 strategies for B and 3 strategies for A. And this is your payoff matrix. So when the payoff matrix is given, I am supposed to find out the value of the game or the optimal strategy. Okay? So now, what am I supposed to do? For every row, I am supposed to find out the minimum value. Fine? For every row, I am supposed to find out minimum value. So for A1, minimum value is 1. For A2, minimum value is minus 4. For A3, minimum value is minus 1. So for all rows, I have found the minima. Right? Row minima has been computed. Row minima has been computed. Next, for every column, find out the maximum value. Say for B1, maximum is 1. For B2, maximum is 5. For B3, maximum is 1. So all the column maximas I have written. So out of all the minima, I am supposed to find the maximum value. That is called maxi-min values. Out of the minima, find the maximum. That is maxi-min. So maxi-min value is max of 1, minus 4 and minus 1. So maximum of these three is 1. Okay. Similarly, what is minimax value? Minimax is out of all the column maxima, find the minimum value. Minimum of all the column maxima. Column maxima is 1, 5 and 1. Out of 1, 5 and 1, which is minimum? 1. See, maximin is equal to minimax. Maximin value is equal to 1 is equal to minimax value. Because maximin and minimax are equal, the value of the game or the saddle point, the value of the game is 1. The saddle point is here and also here. Fine. The saddle point exists and the value of the game is 1. The optimal strategy is A1, B1, representing this saddle point. Then one more saddle point that I have is A1, B3, which is representing this saddle point. Okay, A1, B3 is one optimal strategy, which is giving us saddle point 1, and A1, B1 is one more optimal strategy, which also has a saddle point as 1. So this is how the problem is solved. So do you think the problem is tough? No, right? It is very simple. Given a payoff matrix, for all rows, find out the minimum value. For all columns, find out the maximum value. Out of all the minimums, find the maximum. Out of all the maximums, find the minimum. If it is equal, that is the value of the game. And see where that value is present. See where that value is present. That gives you the optimal strategy. That's it. Very simple, right? Thank you. Thank you for your patient listening. In the next session, we will take maybe 1 or 2 more problems and then go into games without saddle points. Here, the example that I have taken had a saddle point. If at all I don't have a saddle point, how to solve the game? That we will be looking in the next session. Hope you people have understood. Thank you. Have a nice time. Enjoy. Kindly be home and be safe.